Hi guys, here is lesson 101. It's called Solving Multi-Step Absolute Value Inequalities. So we are going to solve these by isolating the absolute value expression. If you'll remember, to isolate, that means to get something by itself. And so when we get an answer, we're going to have either ands or ors with our inequalities. So when the original inequality is a less than or equal to sign, our answer is going to be an and. And when the original inequality is a greater than or equal to sign, our answer is going to be an or. That will make more sense in just a second. So I put all of my absolute value symbols in pink just because it was easier to see. If I wrote them in black pen, then they looked like ones, and that just made life confusing. So our first question is 4 times the absolute value of x plus 1 is less than 21. So we're trying to solve for the absolute value of x, right? So start by subtracting 1 from both sides. 4 times the absolute value of x is less than 20. Now I'm going to divide by 4. So I get the absolute value of x is less than 5. All right, I'm not quite done yet, right? I'm going to take whatever's inside the absolute value sign and rewrite my problem just how it is. And then I'm going to take whatever's inside the absolute value sign, flip my inequality, and take the opposite of my answer. So here I have x is less than 5, and I also have x is greater than negative 5. So if I was going to graph these, I have 0, 5, negative 5. They're going to be open circles. I want x to be less than 5, so that's going to go this way. X needs to be greater than negative 5. That's going to go this way. So I'm shading between them, which means that this is an and, right? You can leave your answer just like this, and that would be totally fine. But you can also start with x in the middle. You want x to be less than 5, but greater than negative 5. Remember when they're written all smushed together like that? That is an and. All right, the next one's a little bit funkier, right? I have the absolute value of x divided by 2 minus 4 is greater than 2. So you could pause it and solve and see if you are right, or you can follow along. Start by adding 4 to both sides. So I get the absolute value of x divided by 2 is greater than 6. What's the opposite of dividing by 2? Well, I'm going to multiply both sides by 2. So I'm left with the absolute value of x is greater than 12. So I'm going to rewrite it just like I have, and then I'm going to flip my symbol and take the opposite of what's left. So I want x to be greater than 12, and I want x to be less than negative 12. So these are both going to be open circles. Greater than 12 means I'm shading out, and less than negative 12 means I'm shading out the other way. So when I shade out the opposite way, this is an or. So you can either leave it like this, or you could write it with a big or in the middle. Either way is fine with me. All right, let's try number 3. Negative 2 times the absolute value of x plus 6 is greater than or equal to 1. So I'm going to start by subtracting 6 from both sides. Negative 2 times the absolute value of x is greater than or equal to negative 5. Divide both sides by negative 2. Here's where you have to be careful. When you divide by a negative, remember, you flip your inequality symbol. So the absolute value of x is, I didn't even flip it, look at that. The absolute value of x is less than or equal to positive 5 over 2. All right, so x is less than or equal to 5 over 2. And then x, flip my symbol, and find the opposite, right? 5 over 2 is also 2.5. So either way works. You can do 0, positive 5 over 2, negative 5 over 2, or you could write 2.5 and negative 2.5. All right, these are both going to be closed circles because they're or equal to's. Okay, so I want x to be less than or equal to positive 5 over 2, so I'm going to shade this way. X to be greater than or equal to negative 5 over 2, so I'm going to be shading in between them, which means that this is an and, right? Again, you don't need that in your answer, but okay, number 4 is a little different because this time we have an operation happening in our absolute value symbol. So be careful with that. You're still going to start by adding 1 to both sides, but now I have the absolute value of x plus 2 is greater than 12. So I'm going to write what's in my absolute value sign and leave things the same. And then I'm going to write what's in my absolute value sign, flip my inequality, and have the opposite of what's there right now. So if I subtract 2, I get x is greater than 10. If I add 2, I get x is less than negative 10. All right, just kidding. Let's see. Let me show you what I messed up on here. I did not do the opposite. I added 2, right? So let me erase that and try that part again. The opposite of adding 2 is subtracting 2. All right, negative 12 minus 2 is really negative 14. Okay, so x should be greater than 10. Let's see. These are going to be open circles. So greater than 10 means I'm shading out this way. Less than negative 14 means I'm shading out this way. So this is an OR. Okay. 5 and 6, again, look a little funky because there's operations happening inside the absolute value sign. So start by subtracting 4. Absolute value of x divided by 2, plus 3 is less than or equal to 2. All right, so write down exactly what you see without the absolute value sign. Write it down, flip your sign, and your negative answer. So start by subtracting 3. So x over 2 is less than or equal to negative 1. The opposite of dividing by 2 is multiplying by 2. So x is less than or equal to negative 2. Same thing over here. X over 2 is greater than or equal to negative 5. Multiply both sides by 2, and I get x is greater than or equal to negative 10. All right, so 0, negative 2, negative 10. These are both going to be closed circles. I want x to be less than negative 2 but greater than negative 10, so I'm going to be shading between them, which makes this an and. All right, start by subtracting 5. Absolute value of 5x plus 2 is greater than 17. Yep. All right, so write down what you see. Write down what's inside the absolute value. Flip your sign, negative 17. So subtract 2. 5x is greater than 15. Divide by 5. So x is greater than 3. Subtract 2. 5x is less than negative 19. Divide by 5. So x is less than negative 19 over 5. What is 19 over 5? 3 4/5, which is 3.8. Subtract 15, you get 4 left, right? So 4/5 is like 8 over 10. All right, so here I have 0, 3, 4, 5. So we're at 3, and we're at 3.8. So like, oops, like there-ish. Let me stretch this out further. That's hard to see. Okay, we will do 3, and then we'll call that 4, just to make it easier to see. Okay, 3.8 is like there. Oh no, it's negative. Oh my gosh, I'm so sorry, guys. Okay, negative 3.8. Try that one more time. Third time's the charm. All right, how about negative 4, 0, and 3? So open circle at 3, open circle at negative 3.8. We're going to call it right there. All right, we want x to be greater than 3, so I'm shading out this way. And x to be less than my negative answer, so I'm shading out this way, which means it is an OR. All right. Last one is a story problem. The acceptable radius for a tire must not vary more than 1.4 centimeters from 33 centimeters. Write and solve an absolute value inequality that models the acceptable diameter to the nearest end. So if you're just reading this, you probably already know the answer. It cannot be bigger than 1.4 centimeters from 33. So 33 plus 1.4 means that the tire can't be any bigger than 34.4 centimeters. And it can't be any smaller than that in the other direction. So if we subtract, we get 31.6 centimeters, right? So that's my answer right there. But how do I write that as an absolute value inequality? So I know I have some number and I'm subtracting 33, and it has to be less than or equal to 1.4 because I want, I don't want the variation to be bigger than 1.4. So this has to be an absolute value here because I can't have a negative tire size. I'm not too worried about you being able to write these inequalities like this, as long as you can read the story problem and figure out that these would be your answers. I hope that makes sense. All right, there are more practice problems on page 681. Please let me know if you have any questions. Thanks.